Okay, so this is part 2, just some more practice over functions and function tables. So we're just going to go right in on it. So taking a look at number 1 here, it says, oh, I want this to come down. Hang on. There we go. Okay. It says Isaiah is buying jelly beans. How appropriate. Not only are they jelly beans, I'm sure that they're Starburst jelly beans because that's all that should be offered. The rest should be illegal. Anyways, moving on. It's like perfect for me. Okay, in bulk, they cost $3 per pound, and a candy dish costs $2. The function rule is 3x plus 2, where x is the number of pounds to be used, to find the total cost of the x pounds of jelly beans and one dish. Make a table to show the total cost of buying 2, 3, or 4 pounds of jelly beans and one dish. So let's take a look at this. It's showing that we are going to go ahead and input, we are going to go ahead and solve, by putting 3, replacing our x with 2, plus 2. So if we were to do this problem, it looks like this. So 3 plus 2, or 3 times 2 is 6, plus 2 is 8. Therefore, if we were to buy 2 pounds plus a candy dish, it's going to cost us $8. Well, what if we were to buy 3 pounds? So we're going to replace our variable with 3. So here we go. So we have 3 times 3 plus 2. So 3 times 3, orders of operation, is 9. 9 plus 2 is 11. So that would cost us $11 if we wanted 3 pounds. So what happens if we wanted 4 pounds? So 3 times 4 plus 2. So 3 times 4, so 3 times 4 plus 2. 3 times 4 is 12, plus 2 is 14. It would cost us $14. All right, let's take a look at the next problem here. Oops, hang on. Oh, goodness. There we go. Okay. All right, so taking a look at the next problem, it says Jasper hikes 4 miles per hour. The function rule that represents this situation is 4x, where x is the number of hours. Okay, it's already labeled. Make a table to find out how many hours he hiked when he had gone 8, 12, and 20 miles. Notice this is miles, therefore it has to go in the column that is miles. Okay, so we cannot put it in the number of hours. That's not the number of hours, that's the number of miles. So now we're going to work backwards. Okay, now since we're working backwards, we're going to write 4x, because that is our rule, equals how many numbers of miles, which is 8. So now we're going to try to figure out what x is. So we're going to divide each of these by 4. I'm left with 1x over here, and 8 divided by 4 is 2, so we believe it is 2 hours. Let's see if that works. So 4 times 2 is 8. Very good, that works. I'm going to erase this to give me a little bit more room. Next one is 4x equals 12. We're going to divide each side by 4. We're left with x equals 12 divided by 4 is 3, so we believe that it is 3 hours. So 4 times 3 is 12. Check, check. We know we've done it right. And the last one, 4x equals 20. We're going to divide each side again by 4 to isolate that variable to get it by itself. 20 divided by 4 is 5. So now I have 4 times 5 is 20. We know we've done it correctly. Now, it's asking us to graph it. So we're going to use our x and y. Remember, our x goes first, so 2 and comma y, which is 8. And then our next one is 3, comma 12, close parentheses. And our last one is 5, comma 20. So now we're going to go ahead and graph them. So we're going to go over 2 up to 8. Doesn't have to be perfect. And I don't have a lot of room to write my order pairs on here, so that's okay, just because the next one's going to be pretty close. So I'm just going to have them over here. So make sure you have your order pairs written somewhere. Then the next one is 3, 12, so right about there. And the last one is 5, 20, right there. Okay, so there we go. So we have seen that it goes up off of our graph when we are graphing our ordered pairs. Okay, all right, let's take a look at the next page. And on our next page, we're just going to do a couple of examples. We're just going to do 1 and 4, and then we're going to do 5. Okay, actually, let's do 1, 3, and 5. Let's do the odds. All right, so here we go. We're going to complete the function table. So find some room to work. Again, wherever you can find some room. I'm going to switch my color here. Okay, so we are going to do, I'm going to write over here, 3x plus 5. We have to replace my variable with 3, so it's going to be 3 times 0 plus 5. So 3 times 0 plus 5. 3 times 0 is 0, plus 5. 0 plus 5 is 5. Okay, my next one, same thing, 3x plus 5. We're replacing my x with 3, so it's really 3 times 3 plus 5. So 3 times 3 plus 5. 3 times 3 is 9. Bring down my plus 5. 9 plus 5 is 14. Therefore, my answer is 14. And the last one, we're going to replace my variable with 9. So now I have 3 times 9 plus 5. 3 times 9 is 27. 27 plus 5 is 32. Therefore, I get 32. Okay? All right, let's take a look at this next one. We're going to work backwards. Okay, notice we've gotten the input, so therefore we have to work backwards, which means we're going to write x plus 2 equals our output. So if I'm adding 2, the inverse operation of adding 2 is subtracting 2, which means x equals 0. So we believe that x is 0. So 0 plus 2 is 2. Well, that works out. Good. Means we did it right. All right, x plus 2 equals my output, which is 3. So now I'm going to subtract 2 from both sides, get my variable by itself. That cancels out, remember, and I'm left with 3 minus 2 is 1, so we believe that the x is 1. 1 plus 2 is 3, so we've done it correct. Check. And the last one, I'm going to do it over here. X plus 2 equals 8. To isolate the variable, to get that variable by itself, cancel out. 8 minus 2 is 6. We believe the answer is 6. Well, 6 plus 2 equals 8. Check, done. All right, we're going to do this last one, okay, for more practice. It says Whitney has a total of 30 cupcakes for her guest. The function rule 30 divided by x, where x is the number of guests, can be used to find the number of cupcakes per guest. Make a table to show the values. Make a table of values that show the number of cupcakes each guest will get if there are 6, 10, or 15 guests. Then graph the function. So again, these are the number of guests, which means they're going to go in this column because it says number of guests. So 6, 10, and 15 is 30 divided by 6, because we're going to replace it. This is 30 divided by 10, and this is 30 divided by 15. So 30 divided by 6 is 5. Oh my goodness, that is so pretty. Is 5. 30 divided by 10 is 3, and 30 divided by 15 is 2. Okay, so then it says graph it. So we're going to take our x and our y. I'm going to write them over here. Our x is 6, our y is 5, our x is 10, our y is 3, and our x is 15, and our y is 2. Okay, so 6, which is going to fall right about here, and up to 5, right about there. The next one is 10, so in between here, up to 3, right about there. Is it okay that it's going the opposite way? Absolutely. Okay, absolutely. And then 15 and 2, right about there. Okay, notice that it kind of looks like this. Okay, that's perfect. Okay, so we have done it correctly. There was some more example problems for you. I hope it makes sense. We're going to go over some stuff in class, I'm sure. But if you have any questions, come find me. Otherwise, you just got some extra practice on function tables. Good job, mathematicians.